Hello, dear students. Good evening. Very warm welcome to all of you to today's special session on TFR previous year questions and solutions. Okay. I am Lalit Thuwal, invited today as a speaker for this session, and I am really honored to be here and teach such a motivated group of students. So this lecture is being organized by Maths Aspirant group, and I'm very happy to conduct this session for all of you. So here is the plan for today. So we'll be discussing selected TFR PYQs, and I will guide you through the thought process and important techniques and the right way to write the solutions. Know the correct answer in exam. We will focus how to approach these questions logically and efficiently. So as you know that the TFR 2026 exam will be conducted on the 14th December. So you have enough time to practice the PYQs properly. Many students find difficulties while solving this problem and find them challenging. So for that, that is exactly why today's session will be helpful. So I will also be sharing several important resources that will genuinely help in your TFR preparation. So on the Ing Mathematics YouTube channel, I have already solved every TFR question from multiple years, and I will show you how to navigate those playlists so you can study topic wise or year wise. Okay, later, in between this lecture. So one more important announcement that I have completed writing a dedicated TIFR PYQ solution book, which will be published in few days and will be available in Amazon Kindle. Okay, so I will show you a few sample pages from that book so that you get a clear idea about the level of detail and the style of solutions. If you feel it is useful, you can purchase it once it is released. So it will definitely boost your preparation. Okay, so with that, let's begin the session and start our discussion on the first question. So let's start with these questions. Okay, this is from TFR 2025. So okay, so this, let's solve this one first. Okay, so this is question of linear transformation. Let's start with a easy one. So consider the linear map T Rx to Rx defined by Tpx equal to d by dx of xpx. Which of the following statements are correct? Okay, so T is injective but not surjective. T is surjective but not injective. T is bijective. T is neither injective nor surjective. Okay, so see, first of all, to know that T is injective or not, we have to look at that what polynomial are maps to 0. Okay, so see, if Px goes to 0, that means that d by dx of xpx should be 0, right? It means that xpx should be a constant polynomial. Okay, but when can it be a constant polynomial? See, because if degree of px is greater than or equal to 1, then this side degree has greater than equal to 1, but this side has degree 0. Okay, if c is not 0. So it is, the thing is that px must be 0. Otherwise, this cannot hold, right? That xpx cannot be equal to a constant. So it means the map is 1, 1 because it consists of only 0 vector. And to see surjectivity, how do you see? So you should not look like that, okay, pick a element and look at which element maps to it. That also is a way. But see, if you want to know that what is the image, you have to first know the basis of Rx. This is the basis, right? And the image will be spanned by its image, right? I think you know that if you have a linear transformation from V to W, say T is a linear transformation from V to W, and beta I belongs to I, is a basis of V, then the image is spanned by this. Okay, and it will, this map is onto if and only if we get the basis, right? So T of 1, multiply it by x, then differentiate it. So if you multiply by by it x then differentiate, you get 1, right? And if you multiply x by x and differentiate, you get 2x, and so on, you get 3x square, and so on. And this is again a basis of Rx. So it means range is spanned by this. So this will span Rx. So it means that it must be surjective. Must be surjective as well. So the answer is T is bijective. Okay. So any questions? Okay, so let's solve the next one. The question number 10. So this is from matrices. So what does it say? See, uh, I'll tell you that how you solve it quickly in the exam. Okay, see, A equal to 1, 2, 1, 2, 1, 2, 1, 2, 1. Okay, this is the given matrix. So this is symmetric matrix, and what has been asked here, A has a positive eigenvalue, A has a negative eigenvalue. See, there are two ways to solve this question. One way is that you have to stop for a moment and think that is there a clever way so that it can be solved very quickly, and you don't have to waste too much time on thinking that. Okay, sometimes you may, solve directly to it. So see, one may think that let's find its characteristic polynomial, then find the eigenvalues. When we find the characteristic polynomial, then we know that all the eigenvalues are real because it is a symmetric matrix. So the characteristic polynomial turns out to be something maybe complicated and which we can't solve and can't see what are the roots. Okay. This may be possible because I have not calculated the characteristic polynomial, but another way of solving this is this, that first we see the determinant. Okay. So if you find the determinant of this matrix, then I think that comes out to be 0. So can you check it? Is it 0 or not? Let me know if yes.
Yes, sir. Yes.
Yeah, it's 0. So if the determinant of a matrix is 0, that means 0 is one of the eigenvalue, right? 0 is one, an eigenvalue of A. Eigenvalue of A. See, now this is a symmetric matrix. This cannot be a positive definite symmetric matrix, right? Because if one of the eigenvalue is 0, it means it is not a positive definite symmetric matrix. This means A is not positive definite. So if a matrix is not positive definite, what does that mean? Can you tell me in terms of eigenvalues?
It has a negative eigenvalue.
No, it means not all eigenvalues are positive, right? Because all eigenvalue may be 0, matrix may be nilpotent. Matrix may be 0 sometimes. So it implies that not all eigenvalues are positive. Okay?
Yes.
Yeah. So another way, see, another thing is that if we consider this leading principal minor, D2, say D2, we note that D2 is 1, 2, 2, 1, and this comes out to be minus 3, right? Which is negative. What does that mean? That means that, and see, D1 is 1. Okay. So is it a negative definite? It means it is
No.
not positive semi-definite also, right? Because if a matrix is positive semi-definite, then all the principal minors has positive determinant. Or are positive, right? It means it is not semi-positive definite. If it is not positive semi-definite, then what does that mean?
Definite.
Not positive semi-definite. So what does it implies? Can you say something about its eigenvalues?
Indefinite.
Negative eigenvalue.
Yeah, A has at least what? One
One
negative.
negative value.
Yeah, one negative eigenvalue. No, see, we cannot say that it is indefinite yet. Okay, all eigenvalues may be negative and zero. Okay, then it will be negative semi-definite. But see, look at its trace. It is 3, right? If all eigenvalues are negative, say, for example, -3, -5, 1 is 0, then the trace comes out to be 0 also. So at least one eigenvalue is positive. So it has one negative eigenvalue, one positive eigenvalue, and one eigenvalue is 0. Is it okay?
Yes.
Yeah, I mean, this is a way to see, although it is not very difficult if you find the characteristic polynomial, okay? Because one eigenvalue comes out to be 0, you will factor it as a x and as a quadratic, and you can easily solve the quadratic also, okay? So I just want you to, I mean, how sometimes when you cannot calculate, then you can apply these kind of concepts, okay? And that thing you can do, okay? So it means it has a positive eigenvalue and also a negative eigenvalue, okay? So if you have some question, then feel free to ask it. You can raise your hand, okay? I'll call your name then. Okay, so now the another question from matrices. So I want you to solve it. So let's try, okay? Then you have to raise your hands once you think that you have found the correct answer, okay? So this is the question, okay? So you can start now. You have 2 minutes to solve it, okay? So start and raise your hand if you able to solve. Raise your hand, okay? Anyone who knows the answer should raise the hand. Anyone. Even if you have seen its solution, which is done by me earlier in YouTube channels, still you can raise your hand. Okay, very nice. Okay, so let me tell you the answer now. So let A be a non-zero and cross-n matrix with real entries where n is greater than 1. Consider the following statement. So whenever you read the questions in the exam, you have to be very careful, okay? So that when you are solving, you don't miss any of the hypothesis. What it says that a non-zero n cross-n matrix, it is non-zero and it has real entries. N must be greater than 1, okay? Everything should be in your mind, because sometimes, when if you forget some hypothesis, then I mean, conclusions may be wrong. Okay, so If a square equal to 0, then rank of a is less than equal to n by 2. See, a square equal to 0 means that, so you can consider A as a linear transformation from Rn to Rn, okay? So see, this means that A of Ax equal to 0 for all x in Rn. This means range of A is contained in kernel of A, right? Because these are the elements of, as x varies over Rn, these are the elements of range. And when you activate A, you get 0, right? It means the range is contained in kernel A, and that's why the dimension of range of A is rank A, and the dimension of kernel is nullity A. Now, by rank nullity theorem, you have this, right? Rank A plus nullity A is equal to n. So now, can you see? I mean, how many of you can see now the result is true? I mean, the first one is true. Let me know. Okay. So what does that mean? It means that 2 times rank A is less than n. Okay. So this comes out to be, I mean, using this one, okay, in this inequality, you can think like this, rank A plus rank A. Okay. Because this one is greater than equal to this one. So 2 times rank A is this. So this is less than equal to n by 2. So rank A is always an integer. So it means this is less than equal to the greatest integer of n by 2. Okay. Clear, right? Okay. Okay. So now this one. This one says the converse is true or not. I mean, if the rank of A is less than greatest integer of n by 2, then A square must be 0. Then the range must be contained in kernel of A. Okay, is it true, do you think?
No, it's false.
Okay, so can you give me an example?
Idempotent
If
matrix.
Okay, so what do
Idempotent matrix.
idempotent matrix? For idempotent matrix, this need not hold, right? This must hold also, because if you take A equal to I, this doesn't hold. You
one
must
zero
take
zero
some.
zero.
Okay, 1 0 0 0.
Yes, sir.
No, I don't think that that will work. Oh, okay, okay, okay. So you don't want to get A square equal to 0, right? Okay. So 1 0 0 0. So in this case, we see that rank of A is less than equal to greatest integer of 2 by 2 is equal to 1, right? That holds. And we see that, I mean, A square is not 0, right? Is it easy to say? Because A square is equal to A. Okay. So we are done with this. Now, okay, let me ask you few questions, okay? Suppose that A square equal to, it is a linear transformation from Rn to Rn. Okay, so that rank T equal to, no, T square equal to T. Okay, the question is that first one, T is diagonalizable. The second one, obviously over R, okay? Rn is the direct sum of kernel Tn ranked image T, and also Rn is the direct sum of kernel T to the power K and image T to the power K for any K greater than equal to 1. Okay. And the third one is that image T is spawned by, without using Jordan canonical form, can you see that this is true? Rank A is equal to trace of A. Okay, so before that, you can do this one, okay? IV, this one is that image T is, it has a eigenvalue 1, okay? Let me tell you that I want to say. So E1, the eigenspace of eigenvalue 1, V belongs to Rn such that TV equal to V. Okay, so let me know, are these two, this is hypothesis, okay? It is a linear transformation from Rn to Rn, satisfying T square equal to T. So can you think about these examples? No, can you think about these statements, true or false? Okay, so let me give you 5 minutes to think about all these and let me know raise your hands, okay? I will ask you. And those can below their hands who had already raised for the earlier question, okay?
Sir, I think option 1, 2, and 4 is correct answer, sir.
Okay. Maybe.
I think 1, 2, and 4. These are the correct answers for that question, sir.
Maybe. Okay, your answer are noted. So you can think again about the third option, okay?
Okay, sir.
And you can use the previous one for the next, okay, to solve. If you wish, okay, or otherwise you can solve. Okay, each time after few questions, I will give you, I will pose the problems, okay? Whatever comes to in my mind at that time. And I will give you hint to solve those questions, okay? You can try at home. Okay, so yeah, 2 more minutes. Samanita, which are the correct answers?
1, 2, 3, and 4. All are
So
correct.
all are true, you mean? Okay.
Yes.
Okay. So see, how do you see that T is diagonalizable? You can see it, I mean, just see that minimal polymer. You can just do it, I mean, by taking X belongs to here, rank nullity theorem, and then so that to them. And to see this, I mean, you can use this one, okay? And to see this, you can use this one. And 0 and 1 are the only eigenvalues, okay? So that will help you to see it. So let's move to another one. Now we will solve the questions from TIFR part B. We have been hit to solving the questions from part A. Okay, now some questions from part B of TIFR 2021. Okay, so this is one of the, okay, so this is one of the very good problem of uniform convergence. So, and nice constructive map, constructive function of sequences you will see here. Okay, I mean, it is one of nice construction. So see, solution. What does it say? It asks that let fn, this is true or false, okay? So fn 0 to 1 r be a continuous function for each integer n. So this is the I mean sequence of continuous functions defined on closed interval 0 1 if limit n tending to infinity 0 to 1. See that this is the real sequence of real numbers, right? And limit n tending to infinity is integral 0 to 1 fn x square dx is 0, then limit n tending to infinity fn 1 by 2 is equal to 0. Okay, so if you try to construct examples, then it will not really be easy. Okay, so now how to do that? So what do we want? We want this to be 0, right? So see, first, how do you think about the counter example? So the area enclosed by each fn so tend to 0. Okay, so area, suppose that functions are like this, then the area should approach to 0, and but at point 1 by 2 all functions if are constant, then this sequence will not approach to 0. Okay, this is your idea to construct the counter example. Although you will think in both directions first, because this is true or false question. So when you will be unable to prove it, then you will think about the counter example. So this will help you to think. Okay, so you have to think like this. So how now I'm going to construct like this. Okay, so let me change the color. So suppose that the f1 is this. Like this. And f2 is this. Okay, it will go some, and f2 is like this. Okay, and so on. f3 is like this. Okay, not f3, I mean say that they are g1 g2 g3, then I will make some adjustments. So g1 is like this, so that at point 1 by 2 all these are taking constant value. That value, say it may be anything, so say it is 1. Okay, So then we see that these gn 1 by 2 will be 1 by 1. Okay, so it will not approach to 0. But what we are doing is that these triangles are shrinking, right? So area is approaching 0. So what is the area? So say that this is the gn, the nth function is like this. Okay, so this is 1 by 2 minus 1 by what I have to take, I think 1 by 4, and will help me. So why, that I'll tell you later. So 1 by 2 plus 4n. Okay, so nth function is like this. Okay, this is piecewise linear. So you can write the formula. Okay, if you want to write the formula, I mean, you can write that. Okay, so formula is like this: 4n x minus 1 by 2. So if your x is between, so this is for g and x. Okay, for, I mean, I need to make some corrections, some modifications to get fn x. So the, and in the another part, it has value 4n 1 by 2 plus 1 by 4n minus x if x is greater than 1 by 2 but less than 1 by 2 plus 1 by 4n, and it is 0 otherwise. Okay, so now see that what is this? Can you tell me the area enclosed by g and x? Anyone? See, this is equal to the, for example, if you want to understand, for G2, this is the area of triangle G2, right? For nth, what will be? The base will be this 1 by 2 plus 4n minus 1 by 2 plus 4n, right? This coordinate minus this. So that comes out to be, what is the base? 1 by 2n, right? And we have to multiply it by 1 by 2 so that the area of G and X is this. Okay. Now we define f and x equal to root of g and x. Why? Because if we will square, because we want this, right? Integral 0 to 1 f and x squared dx is equal to 0. So that means that now 0 to 1 f and x square dx comes out to be integral 0 to 1 g and x dx. But integral 0 to 1 g and x dx is 1 by 4n, right? And this tends to 0 h and tends to infinity. So, and all these are continuous, right? Because piecewise linear functions and all lines are connected. Now we have constructed a sequence fn, which is sequence of continuous functions, and see that this conditions in condition holds. Okay, but fn 1 by 2 comes out to be fn 1 by 2 is equal to root gn 1 by 2 for each n, and root gn 1 by 2 is 1, right? Because every gn takes the value 1 at 1 by 2, and this comes out to be 1 by 2. So this does not tend to 0, right? Clear? If you have some question, then you may ask me, okay? Although I have explained this question in very detail in my book, and okay, you can look at that. And also, okay, let me show you some glimpse of that. So I'm going to present the screen. Let me know if you can see the screen of my. Anyone can confirm? Hello?
Yes, sir.
Yes, sir.
Yeah, screen is visible,
Yes,
right?
sir.
Yeah, okay. So,
No.
right. Yeah, okay. So this is the book of TIFR written by me. So I have written the solution of this question also. Okay, so this is question 1 in 2021. So solution is like this, disproof. So this is the construction, all thing what I have told you. So everything is written in very detail. Okay, so this is not just a solution book. I mean, it will teach you how to write the solutions of each question because that is required for TIFR. Okay, if you are aiming to get admissions into TIFR or any other research institute, you should know, I mean, how to write mathematical solutions. See, so here is the figure also, which illustrates what I told you. Okay, just to go. So, I mean, let me show you some other parts also. Okay, so here is a question from, TFR 2024, which says that these two subsets on R square are homeomorphic. So see, so everything is explained here, and I also had given wherever the I mean diagrams are required like this. Okay, so there are so many instances, I mean, where I have put the diagrams. Okay, so let me show you the solutions for 2025. In few days it will be published in Kindle. Okay, so I will also be giving another session in Maths Aspirant, and you can buy that, okay, if you want. So here are some, you can see. Okay, so also that you can, okay, so give me 1 minute to come back to the screen. Yeah, so now you can see the question again, right? Hello,
Yes,
Samanvita.
sir. Yes, sir.
Okay,
Yes, sir.
so okay, so let's go ahead. Now, I have one more question from TIFR 2021, which I particularly liked, and it is one of the very nice problem, but I don't think that I had time to explain it because we have only half and maybe, yeah, we have enough time now. So I'll see, okay, if I will get time to explain it, but otherwise you can look at solution in the book, okay, in few days, and it's very nice problem. So now let's solve the question number 19. Okay, so I want you to solve it first. See that if you can do it, okay? Yourself. What can be although the answer you know, but you should know the way to solve it, okay? So your time starts now. You have 2 minutes. Raise your hand, okay? Once you're done, I mean.
Hello.
Yes, hello. Yeah, don't need to tell the answers. Okay, I'll ask you. You can raise your hand. Okay, so let me tell you the solution. Okay, so what it says, let G be any finite group of order 2021 for which of the following possible positive integers m is the map G to G given by G goes to G to the power m as a bijection. First of all, that in this particular case, okay, so G goes to G to the power m is a homeomorphism. I mean, is a homomorphism. Can you tell me why? Anyone? In this particular case, is a homeomorphism. Is a homomorphism. Sorry, is a homomorphism. This is not always the case, okay, that G goes to G to the power m is a homomorphism. So in this particular case, I mean, if the order of G is 2021, then it must be a homomorphism. Why? Can you tell me?
It's a cyclic group.
Ah, okay, nice. So, who told? I want to know your name.
Shankaridi.
Okay. Okay. So see, because this is cyclic group, because order of G is equal to C. 43 cross 47, right? Both are primes, and you see that 43 does not divide 46, right? So by Silo's theorems, it will come out to be a cyclic group. So cyclic means it is abelian. Okay, so G is abelian. G is abelian. So this is a homomorphism. Okay, and if G goes to G to the power m 45c, then what is in the kernel? Okay, let's see that if G maps to identity, that means that G is abelian. Now it is easy to verify that this is a homomorphism. Okay, you can do that. If G maps to identity, that means that G to the 20 G to the power 45 is identity. So all it means G must be identity because 45 does not divide 43 and 47. Okay, or the order of 2021, right? You understand this, right? That G must be E. Because there are no elements of order 45, right?
Yes,
Or
sir.
its proper divisors. I mean, leaving 1. Okay, so G must be 1. So G1, it means the map homomorphism is 1, 1. Homomorphism is 1, 1. So bijection also. Because you have a map from G to G and G is finite, which is 1, 1. Then it is automatically bijection, right? Automatically surjective. Right? It's easy to see, right? So now, but this is a particular case, right? But this is not, I mean, this is in general true that if you define the map from G to G, G goes to G to the power m, and m of GCD of M and G is equal to 1, then the map is bijection. Now this is in general, okay? Order of G can be anything and G may be non-abelian. If G is non-abelian, then it might not be a homomorphism. Then in that case, how do you solve this problem? Okay, see, it is enough to prove what? That, let's call this name phi, okay? I mean map phi. So phi is 1, 1, right? To see, to show bijectivity, to prove bijectivity, dot, dot, dot. It is enough to prove phi is 1, 1, right? Because G is finite. If G were not finite, then this might not, this is not enough, okay? I mean, definitely this is not enough. So, now how do you prove it's 1, 1? Now take that G1 to the power M equal to G to the power M. I mean, images are equal for some elements, okay? Now, your goal is to get G1 equal to G2, okay? And you also have to use this. So how this can be used? Then there must be integers, right? Which satisfy this. Yes or no? 1. Because GCD is 1, so there are integers which satisfy this. So to get 1, what do I do here? That this implies this, right? If the elements are equal, then their powers are equal. So now I multiply both sides by this. This is permissible or not? Let me know. Think. And why I'm doing this, you will get to know. Okay, see, after this step, because I want G1 equal to G2. So I was thinking that how do I get G1 to the power this? So I have done this all, okay? This comes out to be G2 mx. Oh, here side, this side also G2, okay? Mx plus Gy, but these are 1, so G1 equal to G2. It means map is 1, 1. So even if the map is not a homomorphism, G is not abelian, I mean, whatever be the order of G, if the GCD of M is equal to G is 1, then the map must be bijection, okay? You understand this, right? Because these, see, these are identities, okay? Because if you have a group G and you pick any arbitrary element, this thing is identity for all G, right? Okay, so these both things are identity. Right? Okay, any questions?
So what
No.
you said about when G is non-abelian,
Yeah, I mean this
is
proof
G2
works. This proof works for any group, okay? Let it be abelian, let it be non-abelian. This is holds for all. This holds for all. Okay? So see,
okay, sir.
now
So if
yeah, I have a question.
may I
I
ask?
what you are asking, okay? So let me ask you first. I infer that you are asking the same thing. Okay, so if M GCD of M with G cardinality G is not 1, then map is 1, 1 or not. So or not. This is question posed for you. Raise your hand if you know the answer. Correct answer. Okay. If you think that you know the correct answer, raise your hand. Okay, so Pragati, you tell map will be 1-1 or not? I can't hear you. Are you speaking? Not 1-1. Why? Why?
Because there will exist an element of order
Order?
M. Oh, sorry.
Not order M, but yeah, you are in the right direction. So there is some element of order.
Order some prime P
Uh,
dividing M.
Dividing M as well as order of G, right?
Yes.
Okay, nice. So G to the power P will be equal to 1. So G to the power P into something, I mean K, will be equal to M, right? Because P divides M. So I mean non-trivial element also maps to identity, and identity will always map to identity. Okay, so the map will not be 1-1. Okay, so there are elements. Okay, if P is a prime which divides order of G, there are elements of or of that order. This is Cauchy theorem. So this is, yeah, okay. So now, yeah. So what were you asking? Were you asking the same thing or something else?
So same thing, I get an answer.
Okay, yes. So now let's move to the next one. Okay. Yeah, this is from ring theory. So I have tried to take consider problem from, I mean, include problem from each of the sections. Okay, each of the subject which are asked in TIFR, ring theory, group theory, and linear algebra, and metric spaces. Okay, so and this is from ring theory. So yeah, I want you to look it at and try to solve it. Okay, so you have, I mean, think about it. I'm not assigning or giving a specific time limit, but think about it, because you will face problems like this in the exam. Okay, think about it, that how do you think about this quickly? Okay, and try to solve it and raise your hand. Okay, Sri Sindhu, it is true or not? You raised the hand. No. Okay. Okay. Okay, so let me reveal the solution. This is not true, as Sri Sindhu said. So, see, there exists an injective ring homomorphism from the ring, this ring, right? To this ring. So we want that it gets I mean, it is asked that does it get embedded in this one? Qxy over x minus y square. Okay. So note that this ideal is not prime. Why? Because it's very visibly clear that this is generated by this, right? I mean, this is equivalent to this. So, by the way, this is not prime. Okay, see, x minus y does not belongs to this, right? X square minus y square and x plus y also does not belongs to this, but their product belongs to this, right? Their product is in the ideal. I mean, their product is the generator itself. So it means this is not a prime ideal. So quotienting this ring by a non-prime ideal, what do you get? A non-integral domain, right? You don't get an integral domain. So this is not an integral domain. Okay? Not an integral domain. Right? So it's easy to see, right? That these elements are not here. Or you can't see. You feel difficulties to see such kind of things. Because in double variable, some students get confused. So I mean, it's easy to see because see it as a polynomial in x and also this. So whenever you multiply, I mean, any element from this, then you get, I mean, degree of, you know, here, I mean, sorry, x square minus y square into fxy because the element will be of this form are here. So its degrees in x at least 2, right? But its degree is 1. So that's why, okay? Now, on the other hand, can you see that why this is prime element? I mean, why this is irreducible polynomial, you can say.
Sorry, if you take x to y square and y to y, it will be isomorphic to q of y. So which is an integral domain.
Okay, so see, but why this is prime? Okay, fine. This is irreducible polynomial or not? Let me know first that.
It is irreducible.
Why?
By the looks of it, it doesn't seem like it's reduced to any sort of
But this
smaller
is,
polynomial.
yeah, I mean, sometimes it might be okay. We should have the region that why is it is an irreducible polynomial. It's easy to see. See that look this polynomial in this ring, okay? And both are isomorphic, and I think that you know the isomorphism as well. So I mean, x minus y square goes to x minus y square, okay? So this is a linear polynomial here in this ring, right? just see Qi as R, a ring R, and the coefficient here comes from R, right? So this is a linear polynomial in X, and linear polynomials are always irreducible, right? So irreducible, hence prime. Hence prime. Why it is irreducible implies prime? Why? You know that, right? In UFDs, primes and irreducibles are same. This is a UFD.
Yes, sir.
Okay. So it means this is a prime ideal. And the quotient is integral. The quotient must be integral domain. Integral domain. And if it is integral domain, that means that any of its subring means we assume that it contains unity, is also a integral domain. But it is not an integral domain, so it cannot be embedded inside this one, right? Because otherwise that will imply that this is also an integral domain. Yeah, so in this way, you can solve this. So this is again false statement. Okay, now let's move the next one. Some questions from TFR 2019 part B. Okay. This is from linear algebra as well as, analytical. So solution. Consider the set A is the set of all 3 cross 3 matrices from M3R. All M3 cross 3 matrices whose characteristic polynomial chi of M, chi M x is equal to this x cube minus 3x square plus 2x minus 1. Okay. Then A is a compact subset of M3R. Okay. Compact means it should be closed and bounded. Okay. So the first question is that is it bounded? And this statement is false also. Let me tell you in advance. So can you show that this is not bounded? Try to show that. And see, you can consider the maximum this metric, okay? Metric here, D of AB is not AB because A is already used. So difference between M and N is this max of Mij, Nij. Okay. See, so let me tell you now the answer. Okay. See, if eigenvalues are all real, say PQR, real eigenvalues. Then consider these matrices. an equal to, consider this sequence P, Q, R, and N, otherwise 0. Okay, these belongs to A, right? So because the characteristic, suppose that all roots are real, I mean this matrices has all its roots are real, then in that case, then these kind of matrices all are in A, right? Because it will be factored now like this, x minus r. So, and this is unbounded, right? So there exists a m belongs to natural number n such that norm of an is maximum entry of an, right? So maximum entry will be n, right, after some stage. Yes or no? Because see, PQ are fixed, but n is varying. So it will be greater than all of PQR after some stage. So that's what I have written here. It means the norm of an s tends to infinity as n tends to infinity, showing that A is unbounded. But this is one case, okay? And it's very easy to see, right? So how do you think about such kind of counter examples? I mean, how do you construct such kind of uh, sequences inside that set? So first we try to look at what kind of matrices it can have, okay? So this will consist of those matrices whose characteristic polynomial is this. So if PQR is the roots of the this polynomial, then all these if the diagonal element are PQR, then this is a matrix which belongs to A also, and we can put n, right? And we can make it arbitrarily large. Okay, so that's why I mean, you think about examples. Okay, now, but all reals can, all, I mean, all roots need not be real. So in that case, you just have to modify your example of n. What you can take, suppose that it has the roots like this. At least one real root will be there. Okay, so gamma is equal to, maybe it will be real. So alpha, beta, gamma, and I mean my gamma and r are same. So then in that case, you can take this block matrix R, and I mean 0, 0. You can put here n, I think 0, 0. So its characteristic polynomial will be, oh sorry, here will be minus b, right? So it's a root. I mean, what will be its characteristic polynomial? Whose roots will be alpha and beta, right? Because the see trace is 2a and the determinant is a square plus b square, same as their product, right? Okay. I mean, it's easy to construct, right? Because now what I'm going to, because if the roots are like this, so I want to make some entry uh, arbitrarily large, and also the characteristic polynomial should come with roots this alpha, beta, and gamma. So I try to break it in blocks. So here we will have a 2 cross 2 matrix whose roots are whose characteristic polynomial roots are a plus ib and a minus ib, and here we will have a one block which is r. Okay, that's easy to construct. But here you can take any matrix whose roots are alpha and beta. I mean, characteristic polynomial should come look like this. Sum of these, and here the determinants. Okay, 2x. So in this case also, norm of n is after some stage comes out to be n, and n is arbitrarily large and large. Okay, so this means that in that case also A is not bounded, so A is not compact. Now, in the book of TIFR, what I have written, so what I suggested you to look at, I have, in general told you your technique. I mean, other than this, that in generally, in case of M and R, not only n equal to 3. So by a beautiful argument that this set need not be compact. Okay, and this set not compact. Sorry, need not compact, not, but it is never compact. Okay, so you can look at that also. Now this one. So let us solve this one. So can you think about it now? So I really want you to solve it yourself. Okay, I mean, put your all effort to solve it. Okay, then raise your hand if you are able to solve it. If you're done, then raise your hand. Okay. Okay, so I'll give you some hint. Okay, see, there exists an injective ring homomorphism from the product R cross R to CR, continuous all real valued continuous functions on R. So depend on R. So if there is an injective homomorphism, then what does it mean? It means that CR has a subring isomorphic to this. Okay, so try to think that if does it have a property, some property which is does not have, which is breached under a ring homomorphism. Okay, if you want to counter it, obviously this is false. Okay, so let me tell you now. So can you think now? So ring homomorphic preachers, nilpotent elements, idempotent elements, and all. So you can try now. These are is, I mean, enough hints, I think, to tackle this problem. Okay, see, the number of idempotent here. Okay, Samanvita, what is your, I mean, what did you use? Let me know.
Idempotent property and important property. That 0, 1 and 1, 0 are the idempotent element. Nilpotent, like
Okay,
they're zero divisor, right? 0, 1 and 1, 0. So
zero
if
divisors.
0, 1, since it, so if it is an injective map and 0,
Mm.
1 is the idempotent element, so 0, 1 maps only basically phi of 0, 1 equal to 1.
Why?
Otherwise,
Why it must be one?
because it's an idempotent element,
Okay,
the constant function one, yes, and 0,
so if it is
for 0,
idempotent,
1,
wait,
so it
if
maps
it
to 1.
if it if it is idempotent, then it it should map to some idempotent element. So why do you think that
Yes, sir.
it should map to 1?
There does not exist any idempotent element except one, the constant function
Okay,
f of x
okay,
equal to 1.
okay, nice. You are done. Okay, you are right. So see, these are the idempotent element, right, of R cross R. Everyone know. But what are the idempotent here? It means f square equal to f identically, right? So that means fx equal to fx minus 1 for all equal to 0 for all x in R, right? So it means fx equal to 0 or fx equal to 1 for any x. I mean, if you pick a x, then either its image is 0. Since f is continuous, so it cannot take the value 0 and 1, okay, simultaneously. So it means f is identically 0 either, or identically 1. Okay. So 0 and 1 are the only idempotent, but here 4 idempotents should go to 4 distinct elements because injective homomorphism. Okay, if there exists some injective homomorphism. So there is no injective homomorphism. Okay. So algebra questions are, I mean, very easy, right? In the TIFR exam. So see, now you have, I mean, was the solution. Now you have known the solution of this. So see, if you want to solve the previous year PYQs and having difficulties and want to see the solutions, so let me tell you. Okay, so what I told you that I will tell you the resource from where you can access the TFR PYQs. Okay, so here you can go to the 𝕟 Mathematics YouTube channel. You can search 𝕟 Mathematics, then you will get this and go to the home page. Then here you will see that all the TFR solutions have been listed year wise, and also these are the complete solution playlist. You can watch it. Okay, so there are some videos which might not be publicly available, and those can be watched in a very minimal cost of 199 rupees per month only. Okay, just by joining this channel, and it has solutions of many of the many exams PYQ. Okay, exams of PYQs of many exams. So CSAT net solutions and crash courses, NBHM solutions, GATE solutions, okay, CMI solutions, IIP, ISI PhD solutions, a lot of things, ISI MS solutions. So you can watch it and enhance your preparation. So, okay, so before we say goodbye to each other, I think I may pose some problems here. Let me know if you can answer. Okay, so let me present the screen again from my iPad. And you can
Yes, sir.
also, yeah, can you
I
see?
have one doubt.
Yeah, please feel free to ask.
Here f square is concurrent to f. Then
F is,
f of x into f of x minus 1 is equal to 0 for all x. But
yes,
how you considered finally f of x is equal to 0 or f of x is equal to 1?
because see, for now fix a real number x, okay? So these are just real numbers. The product of, for, I mean, if you fix x, then these are real numbers, right? Fx is a real number and this is also a real number. So the product of two real numbers is 0, means one of them must be 0, right?
Yeah, but it's not an integral domain. We cannot split like this because
Uh,
there are many other possibles there. We can some multiple of this function equal to 0, but without they are not equal to 0.
Okay, so
Suppose
let me,
consider closed interval
Okay,
Suppose 0
wait.
to 1, 0 to
Yeah. Wait, let me go step by step. Okay. So you have this, right? F square x equal to fx for all x, right? If f square and
yeah.
f are equal. Okay. So for all x you have, yeah, okay. Let me tell you that this is point-wise product of functions. Okay. You might be thinking composition. So let me clear that first. Because see, it is written that point-wise addition and multiplication.
Point-wise addition and multiplication.
You might have missed that. If you are, uh, interpreting it as a composition, that is not true. Otherwise, see, fx, right? So this thing is, this side is fx into fx. Okay, this is not f of fx. Okay, so this you have, right, for any x. So now this you have, right? So far is it clear?
Yes, sir.
Now, because for a fixed x, this is a real number and this is also a real number. So one of them must be 0, right?
Yeah.
So it means, now see, f is a continuous function. So either it cannot take 0 and 1, 0 and 1. Okay, so it will take either 0 for all values or 1 for all values, right? Right? So now
Okay.
ask if something, if something is unclear. I think it makes sense now, right?
Yeah.
Okay, so any other student want to ask some question?
Yes, sir. I have the question. In this
Yeah.
problem, in the ring R crosser, there are four idempotent element you have already written in this board, and
Okay.
if it were injective ring homomorphism, then these all of these idempotent element must map to it
I
the
don't put it.
idempotent element of the CR. Okay.
Yeah.
But how this is possible in mana idempotent element must go to map to it this idempotent element of this side.
Because a ring homomorphism must preserve idempotent elements. So you want to know that why. So the question, let me clear that you want to ask that why idempotent should map to idempotent, right?
Yes.
Okay, this is because, see, because if you have a ring homomorphism from any ring R to S, then if you have a idempotent C, it satisfies A square equal to A, right? Then it means f of A square equal to FA.
Yeah.
Means FA into FA equal to FA. So
Yes. Okay.
FA
Okay. I
square
got it.
also.
Got it.
So the image must also be idempotent. Whatever
Yeah.
is different in the compositions, in terms of composition, must be preserved under ring homomorphism because that preserves compositions. Okay.
When, sir, or I have another question. When we have to check some ring homomorphism, then first point, if we check the identity, zero element goes to zero, whether zero element goes to zero or the idempotent element goes to idempotent element. Uh, at least these two conditions are to check by first.
It depends on the question. Every time, not every time, this thing is going to help you. Sometimes there are maps which maps idempotent to idempotent. They might not be homomorphous. Okay, this is one
Homomorphism.
of the thing you can check for. Okay, but
Yes.
not every time it will work.
Okay, sir. Got it. Thank you.
Yeah. Okay, so before we end the session, so uh, let me ask you if you want, if any one of you want to share the feedback about the session, then welcome. Please feel free to share the feedback. Okay. Raise your hand if you want to share the feedback. Let me give you 2 or 3 minutes. If you want to share, just raise your hand, okay? Okay, so Varada, yes, please.
Yes, sir. Good evening, sir. My name is Varada. So I've completed my BSc from PSG Krishnammal College. And
Okay,
talking about today's session, I felt it was very much helpful. Like your explanation was very clear and concept oriented, and the fact that you connected each question to its underlying concept instead of like simply solving it, it made me feel the questions as much more approachable. And the pace in which you took the class was also very comfortable. So overall, the session was very much insightful. So thank you so much, sir, for this wonderful session, and looking forward to more such sessions from your side.
yeah, thanks. Thank you so much also. So definitely I'll also, I mean, give more sessions before the TFR exam. So yeah, if anyone else want to share the
Yes, sir.
feedback, yeah,
Yes, sir. Good evening, sir. Myself, Supratim Chandra from University of Kolkata. I have completed my graduation and seeking for admission in masters. Uh, I have already done your two session before this session and today's session. This is
okay.
very well and good approach because you have put 2 or 3 minutes for us on calculation. After that you are going to solution, and the way you have approached the solution is very interesting, and hope for more session. Thank you, sir.
Okay, thanks. So yeah, anyone else?
Sir, I have question to ask.
Okay. So you might ask about after this one, okay? So yeah, Archana,
Hello, sir.
yes.
Sir, I'm Archana. I've completed my BSc. I'm actually taking a drop year for clearing few exams. So, as TIFR is coming, it was really stressful on what to start, and like it was all a vague thing. So, when you started with the question and in-depth explanation, and it was really helpful, sir. As you went in depth, I understood which all topics I have lagged, not only the questions, but which all topics I haven't covered and all. So I really liked the way you explained concept and the question. Like everything you spoke was handwritten. So it actually gave us a clear understanding too. So, sir, is it possible if you could share the notes of today?
Yes, definitely. It's possible to share the notes. I will share the notes of today, and I had also told you I mean, big notes, right? Whatever I have
Yes,
written,
sir.
I mean, a
Yes,
book.
sir.
So in
Okay.
that book, every question is written. Okay, so after few days, I will also give another session here. Then at that time, it will be published, and you may buy that. Okay. So and I will share
Okay.
the notes also. Okay.
Okay, sir. Thank you so much, sir.
Yeah.
Sir,
Thank you
really
so much.
enjoy the section, sir.
Yeah. Thanks.